Hello YouTube. I promised I'd make some videos starting with the solar panels is the first video I'm going to make. As you can see, it's a really cloudy day today, but these solar panels are producing 5,000 to 6,000 watts right now into my batteries and running the house at the same time. So like I said, this is a 19.5 kilowatt solar array. It is a ground mount and they're at 20-degree angle. I would have loved to have them at 40, but they don't make them for 40. The highest you can get is 20, 15, or 10. So I do have a slope, which puts them about 25 to 30 degrees on half of them, and the rest of them's at 20. The ground mounts on this is made out of aluminum, and they are connected with these ground screws right here. The ground screws are 1-inch hex on them with 18 inches deep into the ground. I got really rocky soil up on top of this mountain. As you can see, that huge rock over there, they're all under the ground here. So I had to go with a system like this. Trying to bore 5-foot holes and put concrete in it was not an option for me. But I went with high voltage because it's so much easier to wire a solar system like this. Let me show you. You have your positive and negative line under here underneath the solar panel, and you go positive, negative, all the way down, and then at the back of it you'll have your negative line, and you bring it all the way up, and you got your 2 lines that go into the combiner box. And it's that simple. You don't have to put Y connectors on. You don't have to put branch connectors on. It's all positive and negative, and then 1 line coming back, and then your positive and negative going to your combiner box. Like I said, this is a Disco 8, and it's a fantastic combiner box. And all you do is you take your positives, you put it on 1 bus bar, you take your negatives, and you put it on another bus bar, and it's got 2 bus bars in there. 600 volt, 100 amp bus bars that the box automatically puts them in parallel. So now I've got 72 amps at 346 volts. That's open circuit going into the shed there. But like I said, look how cloudy it is today, and I am still producing enough electricity to run my house and charge my battery bank up for tonight. So I want to put 2 more strings on 2 more solar panels each on the back end there and bring my voltage up to 440, because I have an MPPT charge controller, which we'll go up here and we'll take a look at, and it will draw down that voltage all the way to what the batteries are at that time charging, and put as much amps into that battery bank as possible. You got an MPPT charge controllers, you got PWMs. PWM doesn't hold a candle to an MPPT in my opinion, because that MPPT takes every bit of power. It's like 97 or 99% efficient. And we'll go in just a second here and I'll show you the MPPT charge controller. But I want to show you how I was able to make this whole system and still have the grid and everything. And this is this right here. This is a manual transfer switch. You have automatics and you have manuals. Automatics are really expensive. This manual one cost me about $550, but in the up position here, it will go from the power through the box straight into the house. In the down position, it will come from the solar shed straight into the box and into the house from the inverter. And I can flip right now. I can flip that up and go straight to grid, or I can flip it straight down and go to inverter solar. Like I said, when that is switched off the grid, the inverter will power my well pump right there and everything in the solar shed, and keep it warm or keep it cool. But let's go in the solar shed and I will show you the MPPT charge controller and what it's producing right now. Like I said, right now it's about 2 o'clock in the afternoon and total overcast day. But the MPPT right now is putting out 9 amps at 304. Right now, what it's just did is it draws down and it brings it back down. It checks the battery voltage, make sure it's right, and then it'll go back up to as much as it can pull from the solar panels. Just a minute ago, I was pulling 24 amps into the batteries. But this is my 72 kilowatt 𝗟𝗘𝗧''𝗦. They're 144 pieces of 135 Ah batteries, and I have them put in series, started from down there, crossed over, come up, and then go back up and all the way across as 72 batteries in series, because I put each two of these are in parallel, which makes it a 270 Ah battery. So it's like take 2 batteries, put them together, makes it 1 battery. So it's basically 72 cells hooked up as a 230 volt nominal battery bank. I wanted 240 volt. As you can see, I got extra batteries down here and everything, but I could not fit them enough on the battery shelf. So I cut it down. I left these as spares. But I just wanted to show you the solar system, and that even on a cloudy day you can produce, if you got a big enough system, you can produce enough power to run your house. 20 kilowatts, 20 to 30 kilowatts on the average house will do it. I have 72 panels, but they have all these new, I bought those solar panels about 2 years ago, and I got a great deal on them, so I got them. But now they got bifacials that produce 385 on the front and 100 on the back. And you could, with that system, that would bring it down to anywhere from 46 to 50 solar panels, which could make it smaller in case you have a limitation on where you can put your solar panels. They've got a lot of, and then they got a lot of new technologies in solar panels coming out, and they're a little bit higher, but you buy less solar panels. But I recommend, if I was to do it over again, I would get the no hot spot, no shading solar panels, which means that if a leaf falls on your solar panel or you're shaded, it doesn't heat up the other cells because half of them are not working. And you get as much efficiency out of your cells as possible. And I think they call them no shade, no hot spot solar panels. If I was to do it over again, I would go with the higher voltage solar panels and the no hot spot, no shade solar panels. So that was the solar panels and the ground mounts there. As we progress, I will give you links to where to get the ground mounts, the MPPT charge controllers, you know, the inverter, and everything else. So please like and subscribe to my channel, and we're moving on. The next one's going to be about the batteries and my mistakes and problems I had with the batteries, and how to save you from having to deal with what I dealt with. Alright, for now, my name is Mike. Good luck to you, and talk to you in the next video. Bye.